Hi there, my name is Dr. AJ Kumar, PhD. Um, so a while ago I wrote this clone of Flappy Bird and I keep meaning to do videos on it. And every time I try, what I realize is it's really hard to sort of explain from something that has become this complicated. It's not even a very complicated program, but something that has become this complicated is very difficult to explain starting from the beginning. So I think for the future programming projects I'm doing, what I'm going to do is I'm going to record every single thing I do. So start from git init, making the directory, all the way through to the end of the project, and literally just upload videos of me working on the project. I think that's the only way. I think some other channels will work through the entire project and then do some sort of fake thing where they curate, show you, oh well, here's how you do this from start to finish without making a single mistake. And of course, programming, especially me, I'm pretty new to this language, and I'm not a very good programmer anyway. So there are a ton of mistakes, and if I was writing this again today, I would write it a lot differently, and it's very unpolished, and there's a lot of things I would like to do different. There's a lot of places to go with this, but this was sort of just a toy project. And first of all, let me just show you how it works. So ZX, I did a video on how to install ZX. You can clone this repository. I will try to remember to link it. ZX, run local. And if you have a normal window manager, I have this tiling window manager. If you have a normal window manager, it would pop it open. Maybe if I start playing, would it? No. Maybe it would reset. Oh, god damn it. Anyway, I'm not very good at this game. So, uh-oh. Alright. My high score is 0. Let's see if I can beat my high score. This game is infuriating. It's designed to be infuriating. I can't even imagine playing that on a cell phone. I never actually played it. Anyway, so final score, high score. It doesn't save your high score to the disk. So it says hit spacebar to, if you can't read that, it says hit spacebar to play. Once playing, hit spacebar to jump. It's a very, very simple game. But it's a good game because it doesn't. It's a good game to do as a toy project in Erlang, because you kind of see the value. It's really a non-trivial project. It's slightly non-trivial, and you really see the value of Erlang, the concurrency. So one thing, anything that moves is a process in here. So you know what I'm gonna do? I think I showed this maybe. I did a video about this a while ago, and I don't remember. I didn't watch that video before doing this. I probably will delete it, maybe. I don't know. Maybe leave it up there. Not sure. But let me do ZXH run local, and then observer : start. This is a program called Observer, which is your best friend in Erlang. You go to Applications, Flappy Bird. Hopefully you can see this. So just in this one little simple application, each one of these little things is a thread. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 threads. Just in this, 14 threads. And, here. And this is really the value. You wonder, well, programming something like this with 14 threads, that seems absurd, especially if you're not an Erlanger. But one thing you realize if you do Erlang, especially if you're coming from an object-oriented language, so if you're coming from Python or Java or C++ or something like that, what you will see is that you use threads in Erlang the same way you use an object in an object-oriented language. And in fact, a thread ends up sort of accomplishing what objects were supposed to accomplish, namely encapsulation, and it actually does it correctly, because in an object-oriented language that's single-threaded, if you get some sort of corruption or some sort of error in one of the objects, well, everything has to crash. Whereas in a thread, if something in that thread goes wrong, then only that thread crashes. And so if you have dozens, if you have a chat server, let's say, or an HTTP server, I am going to get back to the HTTP server eventually. If you have an HTTP server and somebody sends some insane input to the server and it causes the parser to crash, something like that, only that thread will crash. Right? You would have a new thread for each person who connects, and if somebody manages to crash the parser, only that thread crashes. It doesn't take down your whole server. And so, weirdly enough, you get this thing where concurrency not only makes it easier to think about your program, makes it easier to program. Your Erlang program ends up being way shorter than it would be in another language. And you also end up getting these really robust systems that are very fault tolerant, and it distributes easily. So if you need to use it on 10 computers, it's just correct. That's really what it boils down to. This is the right way to program most of the time. There are some things that Erlang is a stupid language for, but most of the time, this is just the correct way to program, and that is the way it is. So, you see how the game works, you see what's going on. Let us dig into the code. So, what did I write in the README? These are just notes. I did fix the glitching issue. Alright, so for a while, there's no settings. I did get collision logic. For a long time, it had no collision logic, and so here, let's play again. So if you crash into one of the pipes, it stops. But also, if you crash into the floor, it stops. Now, if this was a single-threaded program, you would never have this weird thing where the bird gets halfway through, and then it crashes. But because it's multi-threaded, the bird and the collision detector are separate threads, and so I think the way it works is there's a collision detector that runs in the background, and then when it detects a collision, it tells the game controller, hey, there's been a collision, stop the game. But the bird is its own thread, and so meanwhile, there's, a few frames after it's already collided and it keeps falling. And, so if this was a professional game, you'd fix that. This is not a professional game. But I wanted to illustrate that. Yeah, so the collision logic, pausing, I think pausing is sort of antithetical to the spirit of that game. So, how does this work? So when you're getting into a new Erlang project, you always look at the top level. Okay, so it literally has two things: stop and start and stop. All right, let's go to the supervisor. So that's the thing that's called here. All right. Exports start link and a init. Got some heartburn or something like that. Start link, it's either OK, so it returns OK PID. Supervisor start link, this is very standard Erlang. This is just boilerplate code. And the thing, there is quite a bit of boilerplate code, but the thing with boring code is boring code is good code after a while. When you do something that's really clever, then it's harder to figure out the next time you're reading it. And in practice, I have a tangerine on my desk and it's moldy. I should probably throw it away. In practice, especially in a larger code base, code is read much more often than it's written, and so boring code that's really easy to read is good. Init, OK, supervisor, soup flags. Yeah, so this returns supervisor flags. So the strategy, one for one. Let's look at the tree again. Oops. Okay. So so the supervisor is the parent process of everything else. And 1 for 1, I think, means that if one of these crashes... No, so... I'm going to have to zoom out. Sorry, I hope you can still see this. So 1 for 1 with intensity 0 means it tolerates 0 crashes every 60 seconds. So if, I don't know, if one of these processes crashes, everything crashes. Alright, base spec, so this is giving it instructions for how to start up the base. So this base down here has to move, you see, because that's how you simulate the movement. So the idea is that the background is fixed and this base is moving, and so that kind of looks like the background is far away and the bird is moving relative to the base, and you notice the pipes move at the same speed as the base. Am I going to beat my high score? I am. By 1. Alright, so this is base spec, bird spec, okay, and these all have very standard startup. Right, and the controller, which is the central game controller, which itself spawns the GUI. I don't know what these must be timers. Yeah, and that's actually another interesting thing. So in a normal game, you have, like, if you were coding this in Python, the easiest way to do it would be you literally put the entire logic of the game in a giant while loop, and then at the bottom of the while loop, you have timer.sleep for 5 milliseconds or something. And so the entire game has one set of global ticks. And so what that means is you have to do all sorts of crazy modular arithmetic if you want things to work on different timescales. In Erlang, instead, well, the base has a ticker, the bird has 2 tickers. One of them, I think one of them is for the wings flapping, and one of them is for gravity. I think that's the controller. The controller, I think the one for the controller is the collision detector. So the controller does the con means controller, and I think this means the collision detector. This one is for the collision detector, so every so often it'll check for a collision. I'm not 100% sure. Or maybe this is the controller updating state. I don't remember. We'll have to look. And the GUI, this one I think is for refreshing. So it has to redraw the screen every, I don't know, I think I have it at 50 frames per second. Has to redraw the screen, and so it has a timer telling it to redraw the screen. Running out of breath. I need to work out more. Pipes. Yeah, so these are the pipes. They have their own timer telling them to move. 1 second. Is that it for the supervisor? Must be. Alright, so let's look. What else do we have? Let's check out let's just go in order. Let's check, what is Scratch? That is a bunch of, I don't know, what is this? Oh, that looks like Scratch code for the collision detection. Let's check out the base. So, how long is this? Alright, this doesn't look too bad. 130 lines of code. Alright. Oh, you know what? There's one of these that has a header. I forgot about this. This is not a good way to program, especially in Erlang. Do not use headers. Headers are cancer. But I am still a newbie, but I was more of a newbie when I wrote this, and I better be recording with the correct microphone. I am, thank God. Alright. So the bird X coordinate is fixed. So when you start a new game, here's its Y coordinate. The bird coordinate default is the X coordinate, and I don't know why that's not colon quote bird Y default, but okay. Screen H is the height. The base height is 112. Base chord. So the way this works is that That's a thumbnail that for the pot. I might have to edit that out for YouTube. Flappy Bird. Let me move this over to my bookmarks. I need to clean out these bookmarks. Alright. Include... No, it'd be in images. Okay. So here are my sprites. So we have the base. Now, the base is longer than the window is wide. And so what it does is it moves the base over until it runs out of space, and then it moves it back. So it does some like modular arithmetic, I think. Right, for a while I was using a bigger base, but instead it's just this little thing, and then, I don't remember, we'll have to see. And then the background, I stole these from Tech with Tim, I think. That was where I got the idea. I saw a video that he did of making Flappy Bird, I think in Python. I didn't actually watch the video, but I'm like, oh, I should do that in Erlang. And then I think I stole his sprites. And so the bird actually has 3 images based on its wings. So up, neutral, and down. And then also notice the bird has an angle. So literally there's a timer to flap the wings, and depending on the wing position it tells the right, you know what it does is I think the controller queries the wing position, and then when it redraws the screen it uses the bird's wing position to pick which sprite to draw the bird with. I think that's the way it works. You know, neutral, up, down. The pipe, yeah, so there's a lower pipe and an upper pipe. Yeah, those are the sprites. Let's see. Okay. Yeah, so base chord default, yeah. Base chord YDEF, what does that mean? So base height. So base chord X default is 0, and Y default is the height of the screen minus the base height. Ah, I see. Okay. Yeah, base chord default. So the base and the pipes, right, they need to move at the same speed, and so literally the way this works, so this is environment tick milliseconds. So literally the way this works, so the way this works is there's this process called ticks. That's what each of these little things out here are. So if we look, yeah, these are FB ticks. Each of these out here, what was I going to say about them? Yeah, so what they do, it's a process that literally just sits there. It receives the message tick, and in a second sends back the message talk. I think that's the way it works. Yeah, tick, and then it, okay. It says tick. Yeah, so it needs, says it sends the message tick, reply to self, reply with, and by default it's talk. Okay. Yeah. So literally it, yeah. And then so each of the messages, each of the processes that needs a ticker, it, as soon as it hears the, as soon as it gets the message talk, it replies back with tick. And this one, as soon as it gets tick, it sits there and does nothing for a second or however long. Yeah, I think you have to, I did some object-oriented nonsense with like getters and setters or something like this. I don't remember. I think there's set reply after. Yeah, this is not the right way to do it, but oh well. Set reply after milliseconds. Yeah, this is not a good way to do it, but reply after milliseconds. And default, by default it's a second, but it you can set it manually, and so each process that has a ticker sets it to whatever tick speed it wants, and that's that. Okay. And then type status. This is the... So it needs to know every single process, except I guess the tickers maybe, need to know whether we're in the initialization phase, which is right after the program boots up. Or maybe this might be a init, I'm not 100% sure. Whether we're playing or whether we're in this game over state. And so everything needs to know about that, I think. But I'm not. We'll see. All right, so the ticks, this is probably the second one that's really simple. All right, and then I think I will take a break after we get through this. Oh, wait. What did I say we were going to do? The base. All right. So, right, include... So this is gen server behavior, and if you're not familiar with Erlang, oh well. You'll kind of... It's one of these things that, that you'll just get and then eventually read the documentation, and the documentation will make sense after you've done it a few times. So it exports chord, which I guess gives its coordinates, its bounding box. This is the base, right, so it has a bounding box. So the chord tells it where to draw, and the bounding box is for the collision, and then play, game over, I don't know. I don't know what those mean. Alright. Play does nothing to the base, but it's here because fuck you. Okay. Why does play do nothing to the base? Because when we start up, we're still in a init. And so, okay. Game over. Right, so the way that all of these processes work is the module will export an API. And what that API is just a front end. So from Erlang code, you don't have to look up and remember exactly what the message protocol is. Instead, you just look at what functions the module exports and call one of those, and then each of the functions figures out, or, figures out what message to send. And then there's a big difference between a call and a cast. So a cast is, well, you know what? They're very similar to the difference between like a text message and a phone call. Okay? A text message, you send it, and then it might get there. It will get there. Erlang guarantees that it'll get there. But you don't sit there waiting for a reply. A call is, it's like a phone call. You call somebody on the phone, okay, and you have to sit there and not do anything else until the other person either picks up or doesn't pick up, and you go to voicemail. I know I'm a boomer because I remember what phone calls are like, but so coordinate, bounding box, play, game over, reset. I need to use my inhaler again. Alright. So startup, start link, init. Right, so here, OK ticks. So we start the ticker. We set the reply after milliseconds to base tick ms, which we got from the header, and then send it a tick. And then the state, our state record, let me split. Our state record. Yeah, so here's our state record. This is the state for the process. And so a lot of the messages will just update the state. So the state ticks equals either, it starts by default as none, or it's none or a process identifier. Okay, and then when it starts, state is #s, s ticks equals ticks. Okay, and then returns OK and then the state. Handle call. So anytime you call genserver call, query module, and then whatever the message is. Who is texting me? That is Craig. Do not disturb. Okay. Yeah, reset just sets the status to an... Okay, so reset is... I think what reset is when you crash and you hit N, that sends everything the reset message. I think. New state, okay, yeah, sets the status to init. Doesn't reply, there's the new state. So, oh yeah, call. So a call is the blocking. That means... What that means is when I send, so if I call somebody, I am not doing something until they either pick up the phone or don't pick up the phone. So it blocks the person who is calling it. Whereas a cast just sends the message and forgets about it. So a call, so this is not the right way to do this. So notice, so the reason I'm saying this is not the right way to do this is because what these are is for when the controller when the controller needs to update the state to do things like the collision detection or to redraw the screen, it calls every one of these processes. It calls the pipes, it calls the bird, it calls, I don't know, the base, and says, hey, what is your coordinate? Hey, what is your bounding box? That is the wrong way to do it. The better way to do it is for each of these processes to send updates to the controller. That is the more correct way to do this than this call nonsense. And I think maybe if I did it correctly, you wouldn't see this, this thing where he's halfway into the base. I don't know. We'll see. Alright, reset, that sets the status to init. Game over. Game over must be when you crash. Handle cast talk. What does this do? New state equals do talk state. So if there's something that's non-trivial that happens, it factors it out to another function. Because you don't want to put a lot of really different behavior inside of different clauses of a function. So it says new state equals do talk state, no reply, new state. Okay. So it gets the new state from doing the talk. Unexpected, if it gets an unexpected message, it logs it and doesn't reply. Okay. Handle info. Info is another type of... I actually don't know what infos are. I think info, they're kind of like casts. I don't know. I should go look this up. I haven't written really like process type Erlang. I write a lot of like math code in Erlang, but that's not like gen servers. Gen server means generic server, by the way. I don't actually remember what info is. I should go look this up and go brush up. I don't know. I will try to remember to include a link to the documentation so you can go read about what that is. Internals, do chord. Right, so this is telling it, so all this stores, this is the base, right, so the base doesn't move vertically. And so all it stores is the offset. So it returns the x and y, right. So x is probably, offset is probably a negative number. It's either 0 or negative, I don't know. Let's see. Craig is, what is he trying? Let me turn my phone off. I don't know why I'm reading that. I'm recording a video. Yeah, bounding box is for collision detection. So... okay. So, the bounding box for the base is constant, and that's what this is saying. All right. This is going to be the end of this part, and then next video I will do a different part. I'm going to have to probably edit this a little bit, I'm not sure. If we're playing, then update. Let's see. So it has to have two different cases to react to a tick. So if we're in this game over state, the ticker is still going. It's still doing the tick-tock thing in the background. It's just ignoring it. Or all it's doing is sending back a tick. So when it gets a talk, just send back a tick no matter what. It sends back a tick. But doesn't change the state. Okay. Yeah, so I don't know what this comment is. Probably I was figuring something out. Status is game over. Send back a tick, because why not? Yeah, because that makes it a little bit more complicated if you have to remember to... Right, so if instead of the ticker just being constant, there's really like no cost to that. If instead of the ticker being constant, I had to pause the ticker, and then as soon as we get back into the init state, turn on the ticker again, that's more complicated. It's easier to just have it keep going, and just, yeah, there's no cost to that. Or no real performance cost on a modern machine. Base always move. Yeah, so it does. Right, so I think I probably was matching on different statuses. Right, so probably during the init I was thinking that the base wasn't moving, but no. Base is always moving. It matches on, grabs the tick and the offset. Okay. Sends back a tick. So when it gets a talk and we're not in the game over state, it sends back a tick. Updates the offset. So the offset is T, right? Add, the environment has a constant velocity. So environment means the base and the pipes. So it updates the offset by a constant amount, modulo tick mod? Why is it called tick mod? Should be... Right, it should... I don't think it should be called tick mod, but oh well. It's not a good name. Anyway, it updates the offset, changes the offset, returns the new state. Alright, that's it for the FB base module. I am going to take a break and also read what Craig has been texting me. Alright, Craig wrote the ZX tool, by the way, so he, pretty smart guy, so when he texts me, it's worth listening to. I wonder, because I know that when I close the window, it crashes the whole program. Does it also crash Observer? That's interesting. Yes, it does. That's interesting. Probably, anyway. Anyway, that's all for now. I will see you in the next video about this. We'll just be reading more of the code. I need a break, though. See ya.